Hello, this is Paul from Foster Tech. In this lecture, we're going to deal with the values. This is a kind of application of integration. We will try to find the value for solid of a revolution. So we're going to define what is solid of revolution. We have two types. So either use disks or washers. Okay, and this type of the method. And the next lectures we were going to touch another method later. So first, let me look at what is the disks mean. So the question is like this. So first we have a region. So here is a region. So if we have this is the axis, the region is the left, the right is a horizontal line, right? So this is a curve on the top. The bottom is what is a horizontal is a horizontal line. And if we have a region, then we rotate or revolve a region around the axis. So we do this rotation. So you can imagine. So if you have this region and then you're going to rotate, see what kind of thing you can find. So it's kind of this, right? It's kind of this we call it solid. This is a solid thing you can find at this time. It's not just a shape in two-dimensional space. Now you find something in three-dimensional space, right? And this time, this is the whole solid. We call the solid of revolution because it's revolved around the axis. But the questions, if we know this curve, we know the region. So how to find the value of the solid of revolution? How to find the value with the volume? So this time the value. Here is the results I was going to show you. The idea is simple. Okay, so for integration is the most important idea for us. So how to do? Cut this in pieces along the axis. Okay, cut in pieces along the axis, and each piece is approximated by what? So you can imagine if you cut in each pieces, if the thick is very small, is very thin, the thickness is very small. So you can imagine what this small solid looks like. Okay, looks like what? A disc, or you can say it's what? It's a kind of disc, right? So or cylinder. You remember, if you can think about it, this disc is a kind of cylinder. Okay, I mean the what? So we can approximate. So by the cylinder, approximate this small shape, the small solid by a disc. What is the disc here? So we can see if this is x just a cut, the thickness we use delta x. Thickness is exactly how long along the axis. So how about the bottom? Okay, the bottom is the area, right? It's a circle. So this disc, the disc means, and the basic idea, if you find the value for each disc, and then along do integrations from the left to the right, do the Riemann sum, and then take a limit. I mean the cut goes into infinity. Okay, the thickness goes to infinitely smaller. This take a limit. That's what? That's the integration, right? So that's the definition of integration. Okay, so the idea. So now we're going to develop the formula. The formula, all we need to do is find the value for the disk, right? What the value for the disk? Okay, if we say AX is the area of the disk, so depends on what? Area of the disk depends on the radius because this is a circle. Okay, and if AX is the area of the disk and then times the thickness or the height, this is cylinder, right? The area times the height is the volume of the disk. The volume of the disk, and then integrate from the left to the right. Of course, this first we say the axis is x-axis. If the axis is x-axis, so what do we need to do? Is integrate from A, the left, to B, the right. Okay, so did the formula. So look at the formula, it's very easy, right? It's a very easy formula. Just find the volume of a disk and then integrate all together. The most important part is how to find the area. So the area of the disk, this is easy. Why? It's just pi times r square. We have a single r, right? If we give you x fixed here, how high this is the r is the value of the function. They see, look at it here. Is how high the value of the function, right? I mean this tau is r. And then rotate, you get a disk. Rotate, you get a circle. You can see the area of the circle is there. And plug this into here, and then do integration. You find what the value. So in this same way, we can find what is the what. So look at it first. Is a ball. So a 3D sphere or ball is a solid of a revolution. Definitely it is. Okay, if we draw a semicircle and then we rotate the semicircle around the x-axis, so we can find a ball. And then we use this formula. We finally find the volume formula we learned a long time ago, like in elementary school, is 4/3 times pi times r raised to the third power. Do you remember that? So how to get this? Okay, so definitely. Okay, if we have the integration method proposed by Isaac Newton, we definitely can easily to find what is the formula for the sphere, 3D sphere. So dx sometimes we call the height of the cylinder or the disk, or sometimes we call the thickness. Okay, this is the first formula. It means if this is a x-axis, however, if this is not an x-axis, if I rotated 90 degree and the axis is here, you can imagine we have a shape is there. This time is not a function, or we can is the function x is a function of y. This time if I get that circle rotated by the y axis, what kind of shape is there the same? However, this is axis goes to y. I mean this goes to the bottom of the y integrated to the top of the y. If I put the formula this time is like this. Okay, so they are the same. Okay, so they are the similar at least. This is the area of the disk, and the times dy is the thickness of the disk, and this time is a horizontal disk. Put and put it together means integration from C to D. Okay. This is the first what is disk. I hope you get the idea. And going to the second washer, I will go much faster. If we have this time, if we have this region what? See, different from the last one, because why? The bottom is no longer along the axis. See, the left, the right, the top, but the bottom one is a kind of curve. Remember the last one? See, the bottom one is on the axis, so that's totally different. Well, look at it. And then if we have this region rotated by the axis, what kind of graph we will get? And this time the solid of revolution goes to this type. Is they are solid. However, the middle, you can see my drawing is not very good, I think. So, but you can see, you can get the idea. The middle one, this is unbody. If we rotated the middle one goes to unbody. I mean, we have a hole, okay, in the middle from the left to the right. This is the only difference from before, from the last one. And this time, if how to do integration, cut in pieces, okay, along the axis. Each cut this time is no longer disk, but the washer. Why? Because the middle we get one hole out, okay, get one hole out. And the same idea, how to find the value of each washer, and the thickness we say is delta x. So, and what the area, right? And this washer is kind of is also cylinder. We need to find the area of the bottom and then times the height or the thickness to get the volume of the washer. So how to find the area? Everyone knows is the big circle, right, minus the middle circle. So this time. And if I give a name this time, the big circle is the radius for the big circle is the radius we call the outer circle, out, okay, or we can say is here from the axis go to the top is what? is the big circle, right? The radius is we call the R outer side. Okay, the middle one is a small circle. The radius we call the R inside. Okay, the inner, this is the outer. Okay, so we can see. And now we can find the area, right? We can find the area of the washer this time is pi r square of the big circle minus pi r square or r in square, right? The big circle minus the small circle, the middle one get out, and this is the area. And we can use the area times the thickness. Okay, area times the height is the volume of the washer. And then do integration because we have an infinite washer integrated together, right? From if this is axis is axis from A to B, okay, dx. And however, it's the same. If this is not an x-axis like a y-axis, of course we integrate from what? From C to D along y, from C to D along y. And you see, that's all the knowledge. So now I'm going to give you example. I have 3 examples for you. Please be patient. And here's the first one. Find the volume of the solid obtained by rotating the region. So where the region? I did not see, right? We did not see. You have to draw the region by yourself. And the region is bounded by the given curves. Okay, here. And probably you can say is a curve. You need to find the bottom, the top, the left, the right. Okay, so all the boundary. Okay, the 4 boundary. And find the region and then what? Rotate the region. See, this is along x-axis. Remember that what? Along x-axis, okay, we need to use x and the dx to do the calculation. Remember that? Okay, so now I don't know what is the region looks like. If the region, we can find a hole on the middle. In the middle, that's a washer. If no hole in the middle, well, that means what? That's a disk. So either one of them, right? What is the region? So what I need to do, I need to draw the graph by myself. So the first, so this is a parabola. Everyone know? So parabola, and this is a straight line, straight line, straight line. Okay, so this is a 4 side, and then now we're going to draw the graph. I'll put the graph here. Okay, I need to draw a little bit bigger. I say this is the x-axis. I say this is the y-axis. So this is our region, and this y. I draw this first. This is y equals x squared. I draw this parabola open up, right? Y is positive. I roughly draw like this. It goes up, goes up, goes up, goes up, goes up. Okay, I'll stop at here. And then what is the other side? So y equals 0 is the x-axis. X equals 0 is the y-axis. X equals 1. I have to draw x equals 1 like this. Okay, if I say this is 1. Now I think you can find it, right? So where's the region? So the region is, so this is the function, right? Y equals x squared. Good. So this side is what? This is x equals 1. So this is y equals 0. Okay, so we have x equals 0 is there, but we don't need. Now we can find the region is like this, right? So this is the region. This is the region formed. And good. What do we need to do? This is the region, and then we need to rotate the region about what? The region about the x-axis. Good. How to say? If I draw like this, see? Can you see? Imagine what does this mean? Rotated this region along the x-axis. How do you think about the solid? This time the solid is no hole inside. No hole inside, right? Why? Because the bottom, remember the bottom is a long axis. If we have this one is no hole inside, means we only have one radius. Okay, we don't have a radius in, right? We only have one radius out. Okay, means what? This number we know. This number we know So over here should be use the method of disks, right? Good. We determine this first, and then what's the formula I put here? The formula should be V. Remember this equals integration. Already we integrate, cut each pieces, and integrate from 0 to 1, from 0 to 1. AX is the area of the disk. This time is the disk area of the disk, dx. The formula is there. Okay, and what is the area? So now the questions. The area determines what? Determines the radius. We need to find the radius. Okay, I draw one piece. Is okay. I draw one piece. And for these type of questions, we're going to, and usually we need to draw a basic graph to help us. See, if we cut at this, if we cut at x, if I get this is delta x, okay, from here, and then you can imagine what kind of, see, this is small cut, right? Okay, and I highlight in this way. I mean what? This is not a disk. I cut a small piece, of course, and if you take a limit, that x goes to 0, right? So this is very, very thin. And then remember, it's rotated. This one piece we can get what? If we rotated this one piece, and about the x-axis we can get the disk. This is the disk. That x is the thickness. So where is the area of the disk? Where's the area? And take this rotated, the R is the most important. So this time the R is there, right? So from this point to this point, which means the value of the function at x. The value of the function at x is x square, right? This is the radius. Okay, good. We find it, if we find the radius, and then we can find out what the area. Okay, if we plug that in, easy. Just do this. 0 to 1. Pi times r square, right? What is r? We find it's x square and the square dx. Okay, so we just find out what this is a radius, right? Radius up. Good. And then all we need is just do calculation. This calculation should be easy, right? Because what? Because this power, our directly going to 0 1 pi x fourth power dx, and then power I find that the antiderivative is pi over 5 x raised to the fifth power. Integrate, no, not integrate. The difference between 0 to 1. This is the this is one antiderivative, and then plug 1 is 5 pi over 5, and then plug 0 is 0. So the answer is pi over 5. Okay, we done these questions. Look at it. The calculation is super easy. All we need is the idea. Okay, so how to find what? How to find the, how to imagine the graph, and how to find the disk, the area of the disk is there. Another question. Can we look at this? So similar. Okay, the first step we have to draw graph. I have to draw the graph. So here the same, right? The same functions. However, this side is, these boundaries changed. Let me see. x0, y0. I think this also changed from the last questions. The most important here, totally different. So y rotated or revolve around about the y-axis. The previous one is rotated about the x, right? Okay. Then you are going to draw the graph. What is this? This is a parabola. So there. This is a straight line, straight line, straight line. And then I will get it. It's a very similar. Okay, very similar graph. So we look at the graph this time. I will draw the graph over here. I will draw this is the y-axis. This is origin. Say this is y, and then the graph is like y equals x square is like this. Okay. I stop at here. and x equals 0 is this. X equals 0 is the y-axis. Y equals 0 is the x-axis. Y equals 1. Y equals 1. So that's why I put here. You see, this is the boundary, right? This is one boundary. If I draw a solid horizontal line, this is what? So this is y equals 1. Okay, so I put a 1 here. So 0. This is x equals 0. This is y equals 0. So now we're at the region. So we can find it. The region is here, right? Okay, so we can find it. This is the region. It is not on the bottom. This region, what we need to do? It says rotated by the y-axis. So where are you going to rotate it? I put it here. Okay, so I put an arrow here to say, see. Can you imagine if we do this rotate? Get this area rotated along the y-axis. Okay, what do we get? We get the solid of revolution, right? So is disk or washer? So first, so we need to think about it. And this is the bottom. If we rotate this is the bottom, right? So this also is at the left. And can we find what? Can we find two radius? Or can we find a hole in the middle? No, everyone. You can just imagine. Can we find a hole in the middle? No, definitely not. Okay, definitely not. Means what? This is a disk. Right? If we cut in small pieces, okay, cut disk, put disk together is a form this solid of revolution. So the method this time is still, okay. The method is still the same. It's the method of still disks. Okay, so what we need to do is do the same way. V, the volume, equals what? So integration from 0 to 1 this time. 0 to 1, but remember this time the area of the disk we use y to describe, right? Why? Because it is rotated along y. Rotated along y. The same, all we need to do is find this, find the area. Now as they are going to show, okay, we cut. If we cut y is here, and if I take this is delta y, right? So the disk, the thickness of the disk. What is the disk? Horizontal line. Okay, put it here. And then I should you get it like this. Of course, when you take a limit, delta y goes to infinitely small. And I draw a little bit bigger so we can see it clearly. Okay, and this is the piece. Okay, this is the piece. And then if we take this small piece, rotated, what we get is the disk, right? So from here we can easily to see, okay, this is the thickness of the disk. Where is the area of the disk? So where is the radius? The radius is from this point to this point, right? So what is this point? Of course, it depends on the function. Remember what the, so now we can see, right? So we can see how long from this point to this point is x, right? When you solve this, depends on what is the equation for this curve. I should the equation, remember the equation is there, which means y equals x squared. How to solve this is give you y fixed, how to find the x, right? And easy to find x. And we say was, if I give you y, find the x equals square root of y. This is a positive x, right? That means what? If y fixed, how long is this? From this equation, we can find it is square root of y. And this is r equals square root of y. And this is the radius. Okay, so you find put the radius, go to there, we find the area of the disk. And then we have everything. Now it's just do calculation. What we need to do is do calculation. Area is pi times the radius is square root of y squared dy, right? And this is what? This is radius r, okay, radius. And do calculation, we just do a few more steps. Simplify first. 0, 1, pi times y, and then dy. This is power function, right? So we'll find that the antiderivative is what? Is times 1/2 y squared, right, from 0 to 1. Okay, per log 1, what do we get? Is pi over 2. Per log 0 is 0. See, that's the what? Pi over 2 is the final value. Okay, the final value we find. So you can see this method is very powerful, right? It's not this method. The integration, okay, the integral is powerful. The last questions, I'll look at this. Still similar. It's still similar. So we can see what this is the parabola. This is the straight line, straight line, straight line, and this is rotated about x. Did the same function, right? And now I'm going to draw the curve first. I will draw the what? I will draw the region first, and then going to rotate it. We will find something. I think I will draw like this. This is O, this is Y, so this is X. And the function, the first function, I still going to draw like this. Okay, can you see? Is X is a power, okay? That's square. This square function, if I stop at here, X equals 0 is the left. Y equals 0 is the bottom. X-axis, Y equals 1, so I have to draw this. Sorry. Okay, so this is a 1. So this is a Y equals 1. So what this is? This time this is Y equals X squared. And then the region we can find it, right? The region is still the same region as the previous questions. So this is the region. But this time is not rotated about y, is what? Rotated about x, rotating about x. We can simply draw this. Okay, put it here, so you can imagine what is the solid, what the solid look like. It is still solid of revolution. However, we can find that the middle is embodied. Okay, see, this is embodied, nothing here, right? If we rotate it, we will find what? The middle is like a hole from the left to the right. What do we do? So we need to use what? We need to use what? We need to use the method of washer this time, right? And we have a hole inside. So we have to use the method of washers. I show the formula first. What is the formula? So V equals integration from, okay, so this time. So when you rotate it, the left is fixed. But what the right, I means we need to do this. What is this? What is this? Or what is this point? And in that way we can determine the interval of integration. This is 0 we fixed. What is this? Easy to find it. This is y equals 1, right? See, we need to find this point. We link this and this together, what we can find? Easily to find it. This point should be x equals 1, y equals 1, okay? That means 1, 1, easy to find. If this find, so what is this? This is going to 1, right? Okay, this is going to 1. And then the integration we know is 0 to 1. Okay, and then what is AX? The area of the disk. We only have one formula. Always AX times dx if we use this washer or dishes method or disks method. Of course, not the same questions. We need to find out what is AX. I have to cut it. Okay, I cut the pieces so you can see. Is a washer, right? If it's a washer, whatever, I put this as x. Okay, I put the x here. I put this. The distance is delta x. What can we see? What do we get? Okay, so we will have this. This is inside the region, and then we draw what? Draw a box or or rectangle. Why? Because the disk is very thin. Don't worry. Okay, so the axis is very thin. It's the point to is approach to the zero, positive zero, which means indefinitely small. It's very thin. So what? So we can see this is the x. I do this way. I highlight. So I'm put here, don't worry, I'm put here. So now you can think about this. This is on the region, small part of the region, and then rotate it about the x-axis. We can find a washer. This is where the washer came up from. The washer came up from this. If we need to find the area of the washer, so it should be what? We should define the inner radius and the outer radius. Okay. Oh, where is the outer? The outer is easy from this point to that point. So that's bigger one. You can say I use this. Okay, I hope you can see from the top to the bottom. So this is the big radius. I put it here. So this one is big radius is out radius. How many equals? Everyone knows from 0 to 1, right? So this is 1. Good. The first we find, okay, and the second was the inner. So from the middle to here, this point, or you can say it's simple like this. So how long is this, right? How long is this? Is the value of the function. See, x is there, so this is y, right? This is the inner. The inner equals what? Y equals x squared. So that's x squared. Okay, good. So we find this. I think now we have everything, right? Because what? Because the formula tells us we have to use this, the radius out, the radius in. Okay, so here we going to integration. Now it's just plug into there. So is what? Is pi times outer, okay, which is 1 square, right? The big area, the big area of the circle, minus pi times inner, which is x square. And the square. That's the area of the small. The big area minus the small area is get the area of the washer, and then the x. Okay, that's the formula. Okay, so here is what? Here is the radius, the outer radius. This is the inner radius. Okay, and now it's just a calculation. I simplify a little bit, so we look at it. It should be. Okay, this is pi, I take the pi out. Okay, I put the pi here, and then this is 1, and then this is I guess to the 4th power. Okay, you remember pi is here, and now, and this is the power function, right? It's pi times what? Times the antiderivative. This is x. This is raised to the 5th power, so divided by 5 with 1 over 5 x raised to the 5th power, and then the difference from 0 to 1. Okay, plug 1 into is this is 1 minus 1/5. Plug 0, of course, is 0, and then do calculation is 4 pi over 5. See, we can find the value. So these are all. Thank you.